It gives you a feeling for it. Using the set of axes provided in your answer booklet, sketch the general relationship between the pressure and the volume of an ideal gas at constant temperature. Well, first of all, what we have here, the description before this, I'm familiar with this question, was that picture this as a syringe or a piston, a container with a movable top containing a gas in here, so it can open and close. And they want us to sketch the relationship between pressure and volume at constant temperature. If you recall, PV over T again, if the temperature is constant, so it's PV, when they're side by side, we said that would be an inverse relationship. So if you had to sketch it in the booklet, it would be something like this. And just a curve. We have P versus V, or V versus P, it doesn't matter. That's an inverse relationship. And then they say, in the space provided in your answer booklet, calculate the pressure in atmospheres after the change in volume. So the gas volume in the cylinder is at first 6.2 milliliters, and its pressure is 1.4 atmospheres. The piston is then pushed in until the gas volume is 3.1 milliliters, so the volume is halved, while the temperature remains constant. So you could do this mentally. If the volume is halved, the pressure will be doubled. That's what inverse means. But let's set it up so you can see it. So here we have your first volume, V1, circle and label. Your first pressure, P1. Piston is pushed until the gas volume is 3.1 milliliters. So that's your second volume. And we're looking for the new pressure as the unknown. So P1 V1 equals P2 V2. P1 again is 1.4. P1 is 6.2. P2 is your unknown. You could label it X or just P2. I like to leave it as P2 to remind me that I'm looking for a pressure and remind me that I'm going to need units. And V2 is 3.1. So to isolate the P2, divide both sides by 3.1. And you'll get a P2 of final answer of 2.8 atmospheres. Well, simply put, if you halve the volume, going to double pressure.